Question. This is the most fundamental thing. Numericals very easy. Yeah? Only the theory you should have a clarity. I'm making things clear. Numericals are very easy. Don't bother much. The theoretical part is what? First initial. So there's a velocity of center of mass, Vc. And all points are rotating about angular velocity, this one, omega c. That one. And I'll put a condition, let Vc equal to r omega c. Then I want the I want to study the motion of this object. Let this be a disk of mass m and radius r. So how to describe this motion? So what is the method in the books they're given? The center of mass is moving with a velocity Vc. Then if center of mass moves with a velocity, then all points on center of mass will have the velocity of center of mass. So here, what is Vc? Vc, we can write it as all points will have velocity of center of mass. All points. So what is the primary question? How to calculate velocity of any point on a rigid body? Of all very important, there's a point P, there's a center of mass. Now, this is what it is equal to. There's a rolling disk. It's having a pure rolling. Then this is what? Only translatory motion. According to translatory motion, so what is the basic necessary condition? If we see the velocity of center of mass, then all bodies must have the velocity of center of mass. No? That's what the translatory motion. Plus this is equal to rotatory motion. What do you mean by rotatory? What do you mean by rotatory here? Then all points are rotating about center of mass. Then they will have tangential velocity. that I'll show it here. R omega c. R omega c. Then, sir, what about this point? Yes, this point will have call R and it will be R omega c. All points. And what about center of mass? Center of mass will not rotate. I think you must have, by this time, you must be knowing that one. Then how to calculate velocity of any point? Shall I say vector sum of like a velocity of center of mass and tangential velocity will give the velocity of any arbitrary point. Velocity of any arbitrary point. So what is the velocity of this point here? I want the velocity of point P, which is making an angle theta. How to calculate that? Vp should be equal to, I'll come into these two diagrams. So what is Vp you should write here? Vp should be equal to, we'll write in vector form. Vp bar should be equal to, it is having two velocities. No? So this, if I show combinedly all, let me draw the diagram. Yeah, fine. No. Velocity of center of mass, Vc. Then what is the velocity of this point? This is what needed, no, for us. And what all velocity it will have? Vc and r omega c. This is theta. This is the velocity of point P. So shall we resolve this? This will be theta. Now what is velocity of point P in vector form? Can you write it? Looking at the diagram, please do look at the diagram. And this is R. This is center of mass. Why Vc and R omega c? R omega c is due to rotatory motion. Tangential. This is due to translatory motion. So what is the velocity of point P now? So from the equation, Vp is equal to, let me begin from here. Vp is equal to, in the vector form, what you can write, Vc plus R omega c sine theta I cap R omega c cos theta j cap. And Vc is equal to R omega c. That's what we know it. So in the, I want the speed. I want the speed. So therefore this will be bracket under root of Vc plus R omega c sine theta whole square. Okay, that negative sign, I'm adjusting it. So this will be Vc square R square omega square sine square theta 2 Vc R omega c sine theta plus R square omega c square cos square theta. Any quantities you can make it common. I think R square omega c square. This we can write only R square omega c square. So the velocity of point P, this should be equal to root of Vc square R square omega square 2 Vc R omega c sine theta. Okay, there's a basic formula, and we know Vc equal to R omega c. This is a given. So where all omega c is there, let me write in terms of Vc. Omega c, I'll write it as Vc by R whole square 2 Vc 2R. Okay, I agree this. So this will be sine theta. Keep it here now. So like this, what when I'm able to get now what? Velocity of any point P. Point A, I'll write it because P is what exclusive will use for the lowest point. I'm changing symbol. So like this, how to calculate the speed of any point on a rigid body, there's a formula. Okay, now I'm interested in few very important discussions here. What is the velocity of highest point? There's a formula what we have. Theta is what, make notice, theta is what with respect to horizontal, I'm going to measure here. Now let's look at several points on a rigid body. Let's see that what is the, I think total discussion is available. You can see things very clearly now. So let's go for, what is the velocity of several no, what is the velocity of center of mass? That should be the Vc only. And this was the point, point, and let me take this is point P1, P2, let me take this is P3. Some arbitrary point already we have shown. So if you want, I'll bring that arbitrary point A, that one. Let's come for first, I'm interested in the velocity of point P. How to calculate velocity of point P? So for that, what I should do? What is the value of small r? Small r will become equal to capital R. I want the velocity of this point. what type of motion this rigid body is describing? Both translatory as well as rotatory motion. Directly, I just found the velocity of a point which is in contact with the ground. What is small r equal to? Capital R, right? Capital R. Now, what is theta? So this will be capital R. This will become 2v, no? 2vc square it will become. Then what about theta now here? Small r equal to capital R, 2vc square. Sin theta, how much it will become? 180, 270. Sine of 270, how much it should be? Minus 1, or sine of minus 90. If you want to measure, you measure in this direction. So you are going to measure like this, no? So what is sine of 270 degrees? It should be negative sign. So what is the velocity of point P from the mathematics? From the mathematics, I'll get it. Vp is equal to this is basically I'm starting with this discussion. So first we'll try to learn how to small r equal to capital R. So therefore this will become r square vc square r square plus 2r vc square r sine of minus of 270 sine of 270 degrees theta. So this should be equal to how much? 2 vc square shall I write directly? So this should be 0, no? So therefore what's happening? There is a point on a rigid body which will be at rest when it comes in contact with the ground. When Vc is equal to strict condition, Vc equal to r omega c. This is called like a pure rolling condition. So when a body is having pure rolling, there will be a point on a rigid body whose velocity will be 0. Means at that instant, the velocity of point P will be 0. What about velocity of point P2? Let's come for other one. Now what shall I do in the formula? Theta will be 90 degrees. Put theta 90 smaller equal to capital R. How much will get velocity of highest point? Will become 2 vc. So what's happening to this point P2? It is moving with a speed how much? 2 vc. I want velocity of point P1, speed of point P1. Now for point P1, what we should write? Theta should be 180, no? Theta should be 180. Put theta 180 here. This is theta. The point P1 is this one. Theta will be 180. When theta is 180, I'll make changes. Some of you are asking this, sir, how? This one? At least see the diagram now. Where the point okay, I'll introduce in this diagram only all. Now, what is the velocity of point P1? Shall we write it is equal to root 2 Vc? What about velocity of point P3? Is equal to again root 2 Vc only. Check it. Put theta 0, theta 180. We'll get this one. So like that, what happened now? What we know, if a rigid body is moving, can we find out the velocity of any point with all these are what? With respect to ground. I'm making things clear. The person standing on the ground, can he measure the velocity of any point in a rigid body? Yes, it is quite very simple. So for that, what you should be very good in all these vector sense. You should take the vector sum of velocity due to translative motion and the linear velocity due to or tangential velocity due to rotative motion about center of mass. If you take vector sum of those two, you will get the resultant velocity. Sir, can you predict direction? Yes, the direction will be here velocity of point P1 will be like this. Velocity of point P2 like this. Velocity of point P3 will be like this. What is velocity of point P will be 0. This is what happening to the rigid bodies which are rotating. How to calculate velocity of any point in rigid body? This is a method. Okay, let's come to the next part of the problem. I want to find out the angular momentum. Already I think you know enough, we have discussed. So because now, so what is the biggest problem? I want to find out velocity of any point P on a rigid body. So tell me, so what's happening to this rigid body? It is moving forward. After some time, where it will be? It will be far away from you, no? Say the very next question, why we should study next topic? Why don't you stop here only? Okay, let's do one thing. You have a vehicle. Your father is about to move to some of your native place or somewhere far away, some on business purpose, something is going to go out of station. Then you are going to, then your father will give you assignment for you. What is that? Okay, now you try to, since you know rotation mechanics, your physics sir has taught you very well. Okay, find out the velocity of any point on a wheel of our vehicle after half an hour. So at 8 o'clock you will start morning, 8:30 a.m. you will start. Then you are standing nearby your home, nearby vehicle. So T equals 0, you start counting time. After half an hour, at 9 a.m., your father will call you. Okay, now tell me what is the velocity of a point, some point you will give. What is the velocity of a point on a wheel of a vehicle now in which I am moving? Tell me where you are now. You are almost at a distance of what happened, 40 or 50 kilometer, no? So can you take a reference point which is far away from the experiment? Now a person is doing, your relative is doing experiment in Vijayawada, and you take reference point, you you are in Hyderabad. For every small measurement, what happened? You have to come till Hyderabad and you have to take measurement and go. I think this is stupidity, no? So therefore, the person, the mechanical engineer find very difficult. You will find very difficult. So therefore, no, what type of reference point you want? You want a reference point which should be very near to the experiment. What is the experiment? This rolling body is an experiment. I want to study the motion of this rolling body. Now I want a point which must be near to that. I can't take the ground here, because if I choose reference point a ground here, afterwards I should not change it. So therefore I need a reference point which should be very near to rigid body. I can't take a ground. If I take a ground, after some time, what happens? The body will be here and the reference point will become far away. So therefore, I am searching a point on the rigid body itself where I can measure the velocity of any other point. But always, what type of reference point we prefer? We prefer a reference point which will be always at rest, because it will be easy for us to do calculation. Otherwise, what happens? If you take a reference point which is moving, then what happens? You have to bring relative velocities. I think this will become more complicated, no? Mathematics, all everything. So to minimize mathematics in the calculation purpose, what we are doing, the engineer wants a point on a rigid body which will have zero velocity. Tell me, is there any point on the rigid body which will have zero velocity? Yes, it is. Finish showed. So what is that point? Point of contact. What do you mean by point of contact? The lowest, the the lowest point of rigid body which is in contact with the ground. What happened? It is having zero velocity. So now, how to find out velocity of any point? You take better point P, no, and measure that velocity. Finish showed. But how the motion will appear? You ask two persons. So let me appoint one more person. So what is this? The person is there. He will stand at point P. There's a person on the ground. There's a person at point P. Now let's see that when you take this point as point P as reference, now very next question comes. What this person measures angular momentum? Is it this person also measures same angular momentum? We don't know. That we have to verify. What this person measures the kinetic energy of this rolling rigid body. This person also measures the same kinetic energy. We don't know. That we have to verify. If what according to the ground, what are the velocities we measured? The same velocities what will come with respect to point P, because P is 0. Next, we are not very sure about what angular momentum. Person G, how much measures angular momentum? That much person P measures. We don't know. That we have to check it. How much kinetic energy of rigid body measured by person G? That much is the kinetic energy of the person P. We don't know that one. If both the persons measure same angular momentum, the same kinetic energy S, then I am entitled. Then I was given an authority to describe the motion of rigid body either with respect to G or P. Then in all the rolling motion problems, instead of this G, I'll prefer the P. Got the idea why we are discussing all this? It's all about the engineer. The engineer, for his convenience, has brought this. There's a background. Why that rolling instantaneous axis of rotation has come. There's a background. Finish or nothing is there. Okay, let's do one thing. How to find out angular momentum about axis passing through point G. That's what we'll try to work out the next part of the problem. Shall I scroll down? And the total numerical discussion is like this here. What all we did. I'll scroll down. I think for this diagram only, let me. Yeah. Here only we have no. So let me take help of this diagrams only. Why to again that? Looking at this diagram, write LGZ LPZ. I'll expand it. Already I think we have discussed just now how to calculate the angular momentum. Now, what is this? There's a point. Is a person is there. Then we'll appoint one more person. Where is the person? That person is at the point of contact, not on the ground. The point of the contact of the rigid body with the ground. I think in the diagram I can show only this much here. Is exactly at the red dot. LGZ we need. Just now you have studied, no? LGZ. Once again, I'll repeat it. LGZ is equal to, what should be this one? Angular momentum due to rotating motion about center of mass plus angular momentum due to translating motion of center of mass. Now, this should be equal to what? IC omega C minus K cap. Plus, this should be equal to how much it is? M RGC. I'm writing symbol like this, cross VC bar. And this should be equal to, let me take, I took this a disk, mr square by 2. And since pure rolling, what can be this? RGC VC sine theta minus K cap. How much this should be equal to? LGZ. I think one more step I can go down. Let me write here. So there should be 3 MVC R by 2. So only 3 will not be there. What can be this everything? MVCR K cap. So this everything will become 3 by 2 MVCR K cap. Already we have discussed the same thing. Let me calculate about axis passing through point P and perpendicular to this one. Will be same. but here I'm just changing the problem. Let's come for the original discussion. What is the original discussion? You ask point person G. What he says? I think I'll give separate diagrams here. Let me finish off with respect to ground. Okay, let's find out the kinetic energy also. Then I'll come to the other thing. Kinetic energy. What about the person? Kinetic energy measured by the person on the ground. You will see center of mass having translating motion, kinetic energy due to rotating motion of about center of mass plus translating motion of center of mass. And due to rotating motion, IC omega C square by 2. Due to translating motion, MVC square by 2. This should be equal to MR square by 2 VC by R whole square. Now, who will measure this? Person on the ground. With respect to ground, you write. I'm directly writing person on the ground. So, who will measure this? Okay, let's ask a person P who is there at the point of contact. And what is that? P is what? P is not point on the ground. Point of contact, the lowest point of a rigid body which is having zero velocity. Let's ask the person P. Well, and what this person G will comment? Again, what is the comment by the person G? What will be the comment from him? What you will comment? All points are rotating about center of mass and center of mass is moving horizontally. That's what the person G will comment. No, I think I'll write down that comment from the person G. Person G. These comments are very important. This is the core central idea of all our discussion again. That's why I'm, instead of repeating, I'll put it that one. Percentage what it says. All points are rotating about center of mass with angular velocity omega c, and center of mass is moving horizontally with velocity vc. And this is the pure rolling, vc equal to r omega c. And there's a comment. This comment is very important. All points are rotating. Are rotating is something very important. About center of mass, all points are rotating about center with angular velocity omega c. I'll just shade it. And this was the this comment is something very important. Okay, let's come. We'll ask point P. We'll ask him. So, how do you see the motion of this rigid body? So, what is the point P now? Now, you just assume that a very big, giant vehicle is moving. And what is the wheel? I think if you look at the Discovery, the mega trucks, the mega like a vehicles, they show that one in the America, Europe, no. In the minings, what happened? They will use. So, what is the wheel of diameter of the wheel? The diameter of the wheel will be around 15 meters. 15 meter, 20 meter, that will be the diameter of the wheel. You just imagine the particular trucks itself. They are not available in India, third world countries. In developed countries, Europe, America, that one, what happened? There, that mega trucks are available. The diameter of the wheel will be what happened, will be 5 meter. Means if I stand, no, I may not touch the center of mass. I cannot touch the center of mass here. So that much of big what happened, the wheels are there. You just imagine the truck, like that mega trucks are there. That one. So assume such a mega truck is there, and still more mega truck, like suppose say 30 meter, 40 meter is a diameter. Then you are a very small person, and you come exactly below the point of contact. I think we'll die. It will crush us. Let's imagine a person who is standing at point P, exactly at the lowest point of that wheel, which is in contact with the ground. What is point P? Shall I say point of contact? You are exactly at point P. How do you see the motion of this rigid body? You will say that you will not see anything that one. You will just see all points are rotating about point P. Sir, how it is possible? I think that is what here this proof is giving. No, you look at the velocity of this point. It is like this. So draw a radius vector, and if you measure, this will be perpendicular. And again, you see this is a perpendicular. Again, you see this velocity of point P2 perpendicular to this line joining P2 and P. Velocity of this, you take any point on the rigid body, its velocity will be perpendicular to line joining from that point to the point P. You do one thing, you draw like this. Velocity of point you calculate will be somewhere like this. And you draw a line joining the A and P. It will be perpendicular to this. So this shows that all the points what happen are rotating about point P. This what happens here now. So, but I don't see why you'll not see, because you can never be at point P. No, you can be G only. You can never be point P here. Now, for engineering purpose, the point P becomes very important than point G. So, when you stand at point P and look at the motion of the body, you feel all the points are there's a central theme of our discussion. Some rough diagram. Now come for this. What is the velocity of this point? Let me put one by one. Velocity of this point is like this. What is the velocity of this point? like this. Velocity of this point, velocity of this point. You take velocity of any arbitrary point other than, no sir, I'll take velocity of this point. Are you trying to, so all points, what happen? How they're rotating about point P. Now very controversial I'm bringing here. This is the thing which you have to make observation. Now next question comes. So all points are rotating. Even center of mass, yes, even center of mass rotating. With what angular velocity? With the same omega c. So what this person comments, what this person at this particular point will comment. What is the comment from him? All points rotating about point P. All points are rotating about point P with angular velocity omega c. Rotating is telling, no, not any other motion. That same omega c. Now you can ask me a question, sir, on what basis you are saying that with same angular velocity they rotate? Okay, for that I think I should give proof. So I will find out the kinetic energy of this one. First angular momentum, let me find out. So what is LPZ should be equal to? It is having only pure rotating motion. All points are only rotating. I'm writing only rotating about point P with angles to omega. So when a rigid body is having only rotating motion, what you write? IPZ into omega C. What is IPZ? Moment of inertia about axis passing through point P. It should be equal to IC plus M into the distance PC whole square into omega C. What is IC? MR square by 2. MR square. Now, omega C, what you can write it as? VC by R. Finally, how much I'm getting? 3 R by 2. And what about the direction? Same thing, minus K cap. Now, look at now. Finally, what we are getting? The same answer, no? And let's calculate the kinetic energy also. Here only, let's calculate the kinetic energy. What about the kinetic energy? Kp. This should be equal to what? IP omega C square by 2. What is IP? IP already I know. 3 1 by 2 3 mr square by 2, and this is Vc by R whole square. 3m Vc square by 4. I'll bring the total diagram. Check it now. Look at the kg and kp that. The person standing on the ground, there's everything. Please, I think in mobile you can magnify it. I'll magnify these things, this discussion. Okay, now we have enough space, no? This is very important. This is the heart of, you can say, the rolling motion. Yeah, come for. I think everything is visible for you. Clearly see that total discussion is what I just brought on the screen. And now let's come for this. What this person says, person at point G, all points are rotating about center of mass having translative motion. With what angular velocity? With angular velocity omega c. All points are rotating about center of mass with angular velocity omega c, and center of mass is describing translative motion. And what is the angular momentum? 3 by 2 mvcr k cap. And you'll measure kinetic energy. What is the type of kinetic energy? It is having both rotatory as well as translative motion. I'll add up those kinetic energies, I'll get this much. Now, instead of this person G, I don't like him because they'll be far away from this rigid body after some time. I want a point on rigid body where I can measure velocity of any point. Not only the velocity, even I should able to measure all the things same. Then I can say these 2 points are equivalent. Then I will search, is there any point on rigid body which will have zero velocity? I came to know the lowest point. Yes, there's a lowest point. Now I'll stand here. When I stand here, so what I notice that all points are rotating with the same angular velocity about which they're rotating about center of mass as seen from the ground frame. Then, so same angular velocity means again the angular momentum also is it same? Yes, he measured it. He got the same answer. Then let him measure kinetic energy. He got the same answer. So therefore now, shall I say that to describe this motion of rigid body, tell me like is there any point on rigid body which is equivalent to that on the ground? Yes, the point of contact. So this particular here, all points are rotating about an axis passing through center of mass perpendicular to plane and center of mass having translative motion. What about here? All points are rotating about an axis passing through point P. Shall I say at this instant, this is the center. The point P will behave like an instantaneous center. At this instant, this point P is the instantaneous center. And the axis passing through point P, I'll call instantaneous axis of rotation. Got the idea? IAOR, instantaneous axis. At that instant, point P is the center. So after some time, then what shall I take reference? Any point which comes in contact with the ground, that will become reference here. So means, sir, the reference point is also changing on the body. Yes, it will not be fixed. It continuously changes. That I'll go for the next discussion. All of you got the idea, no? There's a central theme. See, in books, what happen? All the numericals will maximum will do with respect to point P only, because that is what feasible, no? With respect to ground, it's not advisable. Of course, you can solve it, but engineer will not prefer point G. You will prefer point P only. Why this point P we have to come? Because of for our convenient. Now, how the motion occurs. There's another thing. So now I think we have just brought some broad discussion